Be looking at in today's lesson, writing equations in what's called point-slope form. So this is our third form that we're going to have. Now we're going to use this form on Thursday for Thursday's lesson. Okay, the point-slope form in order to solve the type of problems we're going to look at on Thursday. Okay, so the point-slope form, which is the y minus y1 is equal to m times x minus x1. So very simply, the y1 that's going to be, you're going to be given an ordered pair. The y1, that is your y coordinate. x1, that is your x coordinate. Then, of course, the m, that is your slope. Okay, so let's take a look at what we're going to be doing at the first part of your lesson today, writing an equation in point-slope form. So in other words, very simply, we're going to take the three components that we have here. We have the ordered pair, which is our x and y coordinate, and then we have our slope, which is 1/4. And what we're going to do, we're going to take those numbers and we're just going to plug them into point-slope form. Okay? So very simply, to do that, you'd say y minus, well, of course, my y coordinate, which is -2. And that would be equal to my slope, which is 1/4. And then times the x minus x1. Okay, the x1, which is your x coordinate, which would be 3. Now, anytime we have that double negative, we know, of course, we're going to end up making that into a positive. So we just say y plus 2 is equal to 1/4 times x minus 3. Okay, I'm going to give you all one to try. Okay, this one, we have -2, 1, and for the slope is -6. Okay, write that in point-slope form. Okay, so let's take a look at this one. So once again, we're going to plug in our numbers. So we got y minus y1, which is going to be -1, is equal to our slope. Slope is -6. And then times, okay, we have x minus the x1, which will end up being +2, because once again, we got that double negative minus the negative, which will be +2. Okay, any questions on that? You're writing point-slope form. Okay, now the next thing we're going to look at is actually writing these from point-slope form into standard form. So as we've already discussed, okay, with our standard form, which is the ax plus by is equal to c, okay, then also you got to make sure that you meet all three criteria for it to be written into standard form. Okay, so let's take a look at this problem here. We're going to start off, it is written in point-slope form. So now we need to convert that into standard form. We do need to simplify this expression to begin with. So how are we going to, what do you think we could do in order to simplify it? Emma?
Use the distributive property.
You got it. Okay, use the distributive property. So let's distribute the -5. Okay, so when we distribute the -5, we get -5x and then -15. Okay. All right, so, okay, what we need to do here, of course, we need to get the ax and by to one side. We need to get that number, that constant, over there by itself. So, okay, what's one way we could do that? Okay, where would we start? Paul? Yeah, if you add the 5x, you're going to, what are you going to accomplish if you add the 5x? Yeah, you're going to make it positive, aren't you? Okay, and we want that. We want that a to be positive. Now, you may not always get that by on the first step, but if you can do that, go ahead and do that. So let's go ahead and add the 5x to both sides. Okay, and then we're also going to subtract the 7. We can do that at the same time. Okay, we want to move that number over to the other side, opposite the ax and the by. Okay, so now what we're going to get is 5x plus y is equal to -22. Okay, so do we have it in the form ax plus by is equal to c? Are we good there? Can we check that? Okay, we're good there. Okay, does it pass all three criteria?
Yes.
Okay, so a is positive, so we're good there. A and b are both non-zeros, so we're good there. And what was the third one? Okay, do we have a GCF of 1? Yes. Okay, so we're good. So that is in standard form. All right, any questions on that? Okay. Okay, let's take a look at this one. Now, this time we notice on this one, okay, we do have a fraction involved, because it's going to change it a little bit. Now, our first step's not going to change. Our first step's going to be exactly what we did on the previous problem. So that was, what was our first step? Distribute, right? Okay, we're going to distribute. So let's do that first. Okay, now when you multiply 2/3 times 5, what is that going to give you? Okay, we're going to multiply the numerators, right? So we go 2/3 times 5/1. Yeah, 10/3. Okay, now let's go ahead. Negative times negative, so that will be a positive. Okay, we end up with 10/3. All right, now, as we've talked about in the past, with standard form, we can't have fractions. Okay, we cannot have fractions, so we need to eliminate these two fractions. Okay, I want you to think about how could we do that? How could we eliminate those fractions and end up with whole numbers? Okay, give you a minute to think about that. Okay, so how could we eliminate the two fractions? Any ideas? Paul?
Multiply by 3.
Multiply by 3. What do y'all think? Think that would work?
Yeah.
Okay, because when we multiply by 3, now this is the thing, if I multiply by 3 over here on the right, then you have to do what?
Do it on the left.
Yep, you got to do it on the left. We got an equation. Whatever I do to one side, you got to do it to the other. Okay, so really that's 3/1, so I can cross cancel. Okay, then distribute on the other side. Okay, so what we end up with, 3y minus 3 is equal to negative 2x plus 10. Okay, now we can put it in the standard form. Okay, add the 2x. Add the 3. So now we have 2x plus 3y is 13. Paul?
What would you do if it was like y minus 1 equals negative 2/3 plus like 10/4? Like, how would you?
Go ahead and try these two. Go ahead and convert those into point slope form. Okay, with our first one here, y plus 2 is equal to 3/4 times x minus 3. So once again, we're going to start off, distribute the 3/4. Okay, once we do that, we have the 3/4 x minus 9/4. Eliminate the two fractions. We're going to multiply by 4 on both sides. So we end up with 4y plus 8 is equal to 3x minus 9. Okay, then we need to get in the form ax plus by is equal to c. So we end up with negative 3x plus 4y is equal to negative 17, and cannot have a negative a, so we have to divide by negative 1 for our final answer of 3x minus 4y is 17. All right, then on the second one, once again, start off, distribute the 7, and we end up with y minus 1 is equal to 7x plus 35. Okay, get it in the form ax plus by is equal to c. So we end up with negative 7x plus y is equal to 36. And then we cannot have a negative a, so we have to divide by negative 1, or 7x minus y is negative 36. Okay, now the next thing, last thing, concept we're going to look at, writing the equation in slope-intercept form. Okay, of course what we just looked at was writing it into standard form, so now we're going to write the form y equals mx plus b. So in other words, if we're going to write it in slope-intercept form, what variable are we trying to isolate? The y, okay? We're trying to isolate the y. Okay, so just like last time, we started off and we did the distributed properties, so that does not change. We're going to start off the same exact way. We're going to distribute whatever's outside the parentheses. Okay, so once I do that, I distribute, in this case, distribute the 3/2. Now, what I have to do is I have to isolate the y. So, Julia, how do you think I'm going to isolate the y here? Do what? Yeah, that's a good point. Okay, with slope-intercept form, can I have fractions?
Yes.
Yes. Okay, we can with slope-intercept form. We've seen that with slope-intercept form when we graph. We can have that with a y-intercept, of course. We can have that with slope because we have rise over run. So yeah, actually with these, we don't have to worry about eliminating fractions now. Okay. So how do I isolate the y? Yep, just subtract the 3. Okay. Now, when you do that, though, making sure that you're matching up like terms. Now, also keeping in mind when we subtract fractions, here we have 3 over 2 minus 3 or 3 over 1. Okay, before we can subtract with fractions, though, what do we have to do first? Do what? Yeah, got to have the same denominator, right? So we got to rename. So here we're going to rename the second fraction and multiply by 2. So we get 6 over 2. Then we get negative 3 over 2. All right, so for this one, we would end up with, y is equal to 3 over 2x minus 3 over 2. And as we've already addressed, we can have fractions. Now, also keeping in mind, though, can I convert that into a mixed number?
Yes.
Okay, can I convert this into a mixed number? Okay, why can I not convert? I better use this. Okay, why can I not convert this into a mixed number? Paul?
Rise over run.
Gotta have rise over run. Exactly. Okay, y'all try these two. Try these two right here. Okay, let's go. We'll just go through these together. All right, on this one, okay, for the first one up here, y plus 6 is equal to negative 3 times x minus 4. Of course, we're going to start off and distribute the negative 3. So we end up with y plus 6 is equal to negative 3x plus 12. Okay, then we're just going to subtract the 6 for y is equal to negative 3x plus 6. Okay, then for the second one, we're going to distribute the 4/3. Now, the nice thing on this one, we distribute the 4/3. Of course, we can cross cancel with the 3's. So we're going to end up with a negative 4. Okay, then we're just going to add the 5, and we end up with plus 1 for y is equal to 4/3 x plus 1. Okay, any questions from today's lesson? Very good. Okay. Okay, y'all, for this assignment, this will be page 236, problems 11 through 17 on 19 through 34. Now, the first 11 through 17, that's going to be dealing with just writing that in point slope form. Okay, then on 19 through 34, that's going to be a mixture of writing it into standard form and slope intercept form. Okay, then you got a mixed review there at the end.